This is the stock exchange case study. I'm going to use the stock trading data downloaded from NASDAQ's data store for the past 10 years for a particular stock, using the data for trading price, high, low, open, close, and trading volume for the past X days to predict the closing price, to be exact, on a particular day. The technology used was recurrent network with LSTM cells. Training data again was from NASDAQ. Then I'm using TensorFlow back to Keras library for the implementation. Some basic tools were used on my Mac OS 10. Was Homebrew, virtual environment, Python, and pip. And then there's all those libraries required for running the software. First, I do a brood install of the Python version that I wanted. It's Python 3 in this case. And then I'm doing a pip install virtual environment. Um, and so if you're using Homebrew to install Python 3, pip will be installed by default. Then you create a virtual environment that basically create a subdirectory under the name of the virtual environment where you run it, and then repoint your Python into that subdirectory which has all the basic Python software setup. Then you need to activate the virtual environment by sourcing the activate bash script in that virtual environment bin. Um, After that, whenever you do pip install, it will be installed under the subdirectory CSCIE89, and it will not affect your system Python libraries. So you can easily activate by sourcing and deactivate by literally calling deactivate. Then you're going to provide to pip install all the libraries that I mentioned in the previous slide. Downloaded data set, which is not a lot of data, is roughly 2,200 data points for daily trading record. The data is in CSV format. It contains all those columns for date and price and trading volumes. Um, then again, the trading data range was from 2018 to 2018 to 2008, and the data is in year, month, day format. Then it has all the other information needed for training. I'm going to skip ahead and going to show a demo. So the problem here, I'm using 5 features. 4 of those are prices for the stock on that date, and there's a trading volume by share. Then I'm trying to predict the closing price at the end of the day, what the price will be for a particular day. Then in my model, I'm using 20 days look back. That is to say, give me the 20 days of trading data with that 5 feature. I'm going to run through the model and get a prediction of the closing price of the 21st date. Then splitting the data into training and testing, and then further splitting the training data into actual training and the validation in the training process. Um, Building the model, I'm using Keras. Remember to clear the session, especially after running time and time again. You might have an unclear session when you're doing retraining of the new model you construct. Um, so it's a sequential model with 4 layers, 2 of which are RNN layers with LSTM cells. Um, so for Keras RN layer LSTM, it lets you set different dropout rates. That's something I played with a lot, and then find the right balance there to get the best result. Then for 2 fully connected layer um, that has 1 output at the end. Um, the optimizer used was RMS pop, and then the loss function was mean absolute error. So this is a summary of the model that I built. It has 208,000 trainable parameters. After doing the training, and by the way, I'm feeding in mini batches of size 256 and trained over 100 epochs, and plot the training and validation loss over that training period. And that's with the dropout rate I had here. So after training the model, I run prediction on the test set, and plotting that, of course, give you good ideas of how good your model is. Oops, sorry. And then the prediction is in yellow and actual are in red. You can see the prediction is somewhat continuous, whereas the actual is kind of discrete. That's kind of expected. You capture the trend, although in some cases it have some loss over there. Then I run the prediction over the over the training data set. It's quite close because, of course, it's the data it trained on. So one of the big things for adding dropout rate is to fight overfitting. That is, your training set has great training loss, and then your test set is not so great because of overfitting. You can see the model training and validation loss drop down over the training epochs, which eventually reach a roughly good result. And the prediction is not too bad. We capture the trend, which is kind of the point there. And again, I'm reiterating that adding a dropout rate really helped fighting overfit. So before I go to the lesson learned, I'm gonna run through my code. So I'm importing a bunch of things that is needed, loading the data using pandas, reading from the CSV file, then drop it into a data frame. Then have a function to normalize the data into 0 to 1 range, and then replotting that again on the same graph. Give a snapshot of the data, and then loading the data, splitting that data into a 9 to 1 ratio for training and testing. You can see it's over there. And here I am creating the training and testing set by adding the past X day, which is the sequence length passed in of training data for one data train point. And the output, the Y for training and testing, are the zeros index, which is the closing price of the stock on that date. Reshaping that so that I can feed it into my model. So here's the model I showed before, just run through those two. And then I'm adding window size 20, which means give me the past 20 days, I'll give you a prediction on the closing price on the 21st date. Preparing the data, you can see the size of the data is 2000 something. And for each training data point, it has past 20 days, hence the dimension, and then 5 features for the 5 columns in the training set. Then I'm building a model, 5 features with the window size, printing out a summary, which is what I showed before. Trying to train the model by feeding a batch size of 256, then running for 30 epochs. Then the validation split was like 85% of the data was used for training, and then and the other 15% is used for validation during the training process. That's where you get the val loss, validation loss. During this process, you can see the loss is dropping, even though there it dropped. Yeah, then it come back. So I'll let it finish. Then you can see the training and the validation loss all drop down. Now I'm just plotting the validation loss. You can see initially it actually raised a little bit, then slowly dropped down. That blue line is the validation loss, and training loss drops significantly over the training period. And then doing prediction, run model predict on the test set, then grab the prediction dimension data, and then get the actual data, then plot it. So you can see the red dot is the actual, and the yellow dot is the prediction. Here's the method to denormalize it. Remember, we normalized that to 0 to 1, then we need to denormalize that to the real price. Then plot the same data again, but this time it reflects the real stock price of the stock. You can see it captured the trend. Then again, in some cases, it has some loss. Then do the same thing on training data. So this we'll expect a better fitting because it is the training data than this. Well, yeah, you see at the end it has very good fitting. So lesson learned, Keras is a great, easy tool for a program library, I should say, to let you really focus on your model instead of trying to figure out how everything works, trying to set up TensorFlow, worrying about input into different layer, dimension of input into different layers. But with Keras, you can really focus on model add. I really want to tune it for different dropout rates and different types of layers. Then pandas provide a good way and a basic APIs for you to load data in a CSV format and then pre-process it a little bit and then plot it. So all that chart that I get was like this one is just for data frame dot plot, which is really handy. Adding dropout rates again prevents overfitting. However, when I explore the dropout rate, when I turn it up too much, it results a badly fitted model. So some future work I can think of is to get more data, because 2200 is not that sufficient to get a good model. Maybe use some technique of data augmentation, like get better granularity of the trading, perhaps over by hours instead of days. So yeah, so overall it's a great learning experience. I feel like I really learned the tool Keras and Pandas and Python, and then really got a good experience on recurrent network with LSTM cells. So that's it. Thank you for watching.